Thought it might be fun for some of you guys out there to see me do some real-time work. I haven't done that in a bit. I've just got to finish up the last bits on this Mesa SimulClass 295. So I'm going to change out the two fuse holders and the last of those 400 volt orange drop caps. So just get the old wires disconnected. Actually, one thing that's very important to show, I've already done it because I'm not an idiot, but I think it's important for me to show, verify that there's no DC weighting on those switches. There is none, because all these filter caps here are in parallel with each other, and they store almost 500 volts, and they bleed through these two resistors here, which normally I'd want to change, like I changed the others, but to access those, I'd have to remove these caps. It wasn't worth it, and they're working fine. Anyway, it takes a long time for these caps to drain through this, about up to 5-10 minutes. So if you were to go in here and touch a standby location after the amp's been off 3 minutes, you can get zapped. So always verify. Turn off the meter so it doesn't beep at us. And let's get these fuse holders disconnected. And no fancy mechanical connections from Mesa. They're just pushed through the hole, and solder is used as glue. All right, this one was already out because it broke. And this one here, I need to get in there and loosen the nut. Let's see if I can have access to it here. It's a bit tricky. Not quite sure how to do this. Because of this metal lip right here, I can't go from this angle with a wrench, and there's a big power transformer here in the way. There it goes. I mean, in theory, I could go out and find the proper socket wrench and a right angle thing and might be able to snake it under here, but I'm pretty sure they installed these before the transformer is installed. But these plastic nuts really don't grab all that well. So once you get it started, it turns pretty well. I'm doing this up at an angle like this so that you can see well enough, but also I have access to the other side without flipping the heavy chassis around too much. Trying to get this nut off this, and got some excess solder there, of course. So wait for the iron to heat up. I'll just push out the front, and away with the old, in with the new. Due to access, I'm going to install the bottom one first. So this is going to go like this. And just got to get that nut on as tight as I can, which will be at least as tight as factory. Maybe I can get a little bit tighter than that. You don't want it to crack, though, otherwise we end up right back where we started with the broken nut. It's too early in the day to bust a nut. All right, that's tight. And then this one will install facing that way. This is why I don't do a lot of the real-time repairs on the channel. It gets really repetitive and kind of boring to watch, but I know that some crazy subset of viewers really like this stuff. So here's one for you guys. Finding needle nose pliers that are small enough to get where you want and have delicate access, but still strong at the tip so you can do stuff like that. So you can actually get in there and make a nut turn even with the tips. That's tricky. These old Craftsmen have worked really well for me for a really long time. I don't know if they're even being made now that Sears went from the harder side to the softer side to the bankrupt side to the gone side. Anyway, get those bent out. Let's see, this was here. See if I can give that some mechanical support while I'm at it. Same for this one. Doesn't have to be a ton, but a little bit's nice. Much easier to do before the solder on the wire. If I thought it was going to be a make or break kind of thing, I would strip fresh wire or replace the existing wires to be able to have enough slack to strip. I just want to have it so that it's not just sitting in the joint. There actually is some amount of metal-to-metal contact that the solder then is augmenting. Do the same thing on here. Let's see. This one was beneath. Up to that. I already transferred the 1 amp fuses from the old fuse holders to the new ones. All right. Not up to what I like to do in a new build, but better than factory. If I wanted to, if it mattered, I'd go ahead and snip off the little bits of excess, but it doesn't matter in this case. There's not much. It's not close to anything else. Only move this around and move the camera and get you a better view of the next bits. All right, we're going to replace these very large 400 volt orange drop 220 nanofarad caps with these much smaller Panasonic ECQ series 630 volt 220 nanofarad caps. And the amp will be much happier and last a lot longer. Letting the iron come to temp. I'm going here and just add a little bit of fresh solder to each connection before trying to work it. Fresh solder also brings a bit of flux wakes the old solder up. And on Mesas, the solder tends to get kind of gray over time. It loses its flux. Maybe it's a bath they do in the factory, I don't know. And the pads on the board are teeny tiny. So unless you have everything very hot and ready to go, you can really stress things out and cause damage. So now that I've added solder, things should be able to move a little bit. Let me get the excess off my iron. The little Hakko cup thing sometimes comes loose. I need to remember to order a new copper sponge for this thing, whatever it's called. All right, try that again. Heat up the iron. Nice and tinned, aside from a little bit excess on the barrel. Just lifting straight up with no pressure. That one's got some silicone holding it in place. I bet that one over here does too. All right, try that again. It's very important to make sure you don't touch other wires when you're doing stuff like this. On that 64 custom hand-wired monstrosity Fender thing I've got going on at the same time, the previous tech not only botched everything else, but he burnt as many wires as possible. You can see where he was working because all the wires in that area have burn marks and missing chunks of insulation. And if you see me do this in a video and things don't work the way you see them working for me, this is a Hakko FX-951 iron with a 2.4 millimeter tip. I believe that's what it is. Let's see. Next size up is a, this is a 2.4 millimeter chisel tip. You can also use a similar tip in like a Hakko 888 or whatever it's called. If you have a Weller from the hardware store, you're not going to have these results. I'm using specific solder. Links to all the stuff I use are in the description of all the videos. So if you're not having these same results, you're probably not using the right temperature or the right tools. I know I make it look easy because with the right tools, it is. And with the wrong tools, not only is it difficult for you, it's really hard on the boards because you see how quickly that joint came out. I didn't have to overheat everything. I worked very hot, very fast. All this stuff is fine, nothing burned. Now at this point, I want to get the old solder out. I can do that with a good solder sucker. This is an Engineer SS03. It's about 30 bucks. You can use a desoldering station like my buddy Brad uses. I've tried those in the past. When they work, they're great. A lot of times they just clog up the tips. I spent so much time cleaning the damn thing and unclogging the thing that I'm not sure it actually saved me any time. But I might not have had a very good example of one. This was a while ago that I tried that. Now you might notice, depending on the resolution of the camera, that I just let solder remove solder here and remove solder here, I need to remove solder here as well. And I'll go ahead and remove solder here so it's more apparent on the camera. There's a point to this, I promise. I'm almost to the point. These old orange drops have a lead spacing like that. Well, let me bend this one back down. Have a lead spacing like that. And they went to this hole and to this hole. These new Panasonics are more narrow, so I'm hoping that I can just do that hole to that hole and barely have any bend in the cap, as opposed to having to bend it out a lot to get to here. But I'm looking at this and I'm thinking, well, I need to have some bend there, and be better for it to be a little bit larger than a little bit smaller. So what I'm going to do is measure this, and I've got a, can you even see, I don't know if you can see this, you've seen my cutting mat. Got the cutting mat marked, and that is 7/8 of an inch. So I will then take each one of these and go out like that, and go out like that. And then I'll line it up to the lines on my cutting mat and say, all right, I want 7/8 of an inch. And that's about like that. And it'll do, as I get it started, right? It'll go in just like that. Now, I'm not going to put it in like that because the leads are so long that they touch the chassis on the other side. So now that I've got the spacing, I can do the spacing for all four of these, and I can snip off all of it that much, and then it'll have enough contact to the board. It'll go in fine. So before I bend all the caps, I'll show you the cheapest way to get solder on this other side. Instead of a $30 solder sucker, if I can find where my braid went. Instead of a $30 solder sucker, you can use about an $8 roller braid. Of course, you have to go through multiples of these over time. If you're doing what I do all the time, you'll want to have both, and you'll be buying a lot of these and a lot of solder. If you're just doing the occasional stuff, a roll of this and one thing of solder would probably last you, well, the solder would probably last you years. This would probably last you a year or more. Anyway, you want to make sure that you get the good stuff, and you can see what this is in the description of the videos. Not all braid is equal. This is really good stuff. The iron needs to be hot. You put the braid over the solder you want to remove, and you heat up that area through the braid, and it just wicks the old solder up into the braid and gets most of it first try. Sometimes you get all of it first try. Now this does heat up the trace more than using the solder sucker, but there are places where the solder sucker cannot get it out, and this stuff saves the day. That's why you have and use both. But in general, usually the solder sucker is faster. But I got one here where the solder sucker is not getting it all up. I don't know if you can see this. What I found works really well in this situation, especially with mesas, is to add a bit of fresh solder to it. Because that fresh solder will go down and mix with the old stuff, and then you have a better chance of getting it all up. It's a lot of solder in that joint. So let me try the braid again. That did the trick. All right, just these two left. And once again, in this instance, the solder sucker is not getting everything because there's enough on the bottom of the board that it doesn't really, it's not able to grab it. It sucks up the stuff up top, and then the solder kind of breaks inside the tube. If that makes sense. But this is wicking it up through the tube. More than enough for our purposes. All right, there we go. All right, now that I have done that, here and here, where I removed the solder because I thought I might be able to use the narrower lead spacing, I'm putting the solder back because it is in the path. And if it has a hole in the path without solder in it, then there's less current voltage carrying capability there. You can see Mesa left a lot of holes unsoldered. In general, when you have holes in a trace like that, I prefer to fill them with solder. Because of physics. You know, things like that where I've got a great big plane and there's a hole, unfilled hole in that plane, that's okay. But when the hole is the size of the entire trace, it can matter. All right, now I'm going to get in here before I put the new stuff in with just a tiny bit of isopropyl, each of these locations. A small bit of paper towel and get up any of the old flux. I only want my flux to be in there, no one else's. And it doesn't take a lot, but I don't know if you can see that bit of brownish orange there. There is some stuff there coming off the board. All right, so now I will talk about nothing in particular while I bend the other caps to 7/8 of an inch. I don't know what that is in metric, but you people are clever with your scientist measurements. Here, only doctors and drug dealers deal in metric. I know it makes us a backwards nation, but recent events have proved that correct, so. All right, let's see here. 7/8. What you watching? This guy bend wires with his mind. One more to go, and then the excitement continues. And I've got one of these, but I didn't use it. But I guess it would correlate to that one there. Maybe that one. Anyway, it's faster to just use this thing. That thing is not great in terms of keeping things straight. It's fine for a resistor, but when there's an actual axis, you know, and sides to things, it's a bit tricky. I'm gonna go ahead and trim off all the excess. While I'm doing that, let me mention that on some mesas, where you're making a span across things, you might want to leave it longer so it goes more up in the air. In this case, there's not much of a span I've got to worry about. Also, the body of the cap is insulated in those places, so not much of a concern here. All right. Outer foil doesn't really exist on these caps. I like to make sure when I install like this, I do like to make sure that all the text is facing the same way. Just shows attention to detail. When you see someone's work and little things like that are observed, you know they're paying attention to the big stuff too. Like in the plumbing stuff I did, all the PVC pipe, I have all the PVC text facing the same direction, reading from left to right, upside right. So that if an inspector were to come in and see all those little details, he'd know that I didn't miss out on the big stuff. Or at least much less likely to. All right, now they're in place. I'll just solder them. Waiting for the iron to heat up. This FX-951 is fantastic, but when you put the iron itself in the holder, it goes to sleep, so you're not wasting energy or burning out your chips. But it takes a few seconds to wake back up. And you might want to go into the manual and remember how to change that timeout period. I'd like it to be a little bit longer before it does that. I know you can't really see from that angle, but I'm heating up the component and the joint and then bringing the solder to it. I'm not putting solder on the iron and then applying it to the cold metal of the lead and the solder pad. But this iron is so hot that I work really fast. It's really hard to make out sometimes. And these pads are so small, it doesn't take much. All right. And once again, I won't wipe up any flux, but this time I'm just going to do spot flux removal. The isotope applied to the paper towel. I was working around those joints, those solder joints with this little screwdriver. Just clean up after myself. In this case, it's kind of a pride in one's workmanship kind of thing. In other cases, when flux builds up a lot, not in this case, but in other amps you've seen on the channel, they're crusty, big, chunky areas. The crust is a gummy, waxy substance, and over time it traps particles, and those particles can become conductive. So if you had a whole bunch of flux here from this, around this pin and this pin and this pin, and the flux was connected, and over time it just got dirtier and dirtier and dirtier, you could have shorts through the flux, through the dirty flux from pin to pin to pin, or component to component, etc. Pretty obvious stuff. I don't need to beat that particular horse. All right, let me plug this in and hook up a speaker, and we'll confirm that we have signal. I'm just gonna hook up a signal generator. All right, I am feeding it 440 hertz for those of you who might want to tune up an instrument. And I've got it set to negative 10 dB, which is line level. Let's see how this sounds. Take this side out of standby and bring that volume up. Now, I've already done tests on this thing with a scope, and I've already done tests on this thing with the guitar being run into it and all that. I know that it's healthy. I'm just making sure that I didn't miss a solder joint on all this. So I took this in standby, change over to this side, take this side out of standby, bring the volume up. All right, amp is healthy. Power it off. Notice it's powered off, but you're still hearing that sound. It's draining the filter caps. As I turn the volume up, it almost maintains the level. So the volume is cranked now. That's max volume. When I no longer hear any sound coming out, let's see what the voltage is at now, because that's going to apply to both channels. Still got 91 volts DC there. That is draining off. All right, now that there's not enough power to produce sound, I'll take this channel out of standby as well, which will drain these caps here. Otherwise, they'll store all that voltage up. All right, so this thing is healthy, and I will spare you the process of putting this panel and all the screws back in place. That's no big deal, as long as you know how to insert a screw. And if you watch my channel, you do. So there you go. Thanks for watching, guys.